Good evening, guys and gals. Thank you for allowing me to join you. Yeah, the camera's shaking. Supposedly the wind there is about 10 miles an hour. But when I checked on Google, it said that wind was about 6 miles an hour. It's supposed to drop down to 3. And this is for today, tomorrow, which is about 3. Monday, about 1 mile an hour. And currently it's 79 degrees there. So I don't know why the camera is shaking so badly. Yeah, the tree die-off is growing and growing. Look at that over there. And then off over here, you can see a real barren, location. Just terrible what's going on with the trees. It's so sad. But everyone's probably wondering about these 2 earthquakes that occurred today. The one in Haiti, that they upgraded to a magnitude 7.2. And then the one along the Aleutian Islands, that was, a 6.9? How did it affect the Caldera? So I'm showing here first the earthquake that occurred in Haiti, the 7.2. Hard to tell there, but the top one is the signature as it came in at Madison River. The center is Yellowstone Lake. And then the bottom one is Norris Junction. Over here on the left, that would be the earthquake that occurred there in Alaska along the Aleutian Islands. Look how quickly they came in. Yeah, 6.9, 7.2. Okay, so we have here at the top, once again, Madison River, Yellowstone Lake, and Norris Geyser Basin. These are boreholes. Borehole 207, borehole 208, borehole 950, and these are very deep wells. They only show the activity that is going on to be picked up under the ground. Nothing above, not the weather, not the wind, not stampeding tourists, nothing like that. I am happy to report, too, that it looks like the magma coming into the system has settled down greatly. So anyways, let's look at the signature. This is the signature of Haiti. How it stirred up the caldera. And then we'll go to the one in Alaska. Okay. There's the one from Alaska. The 6.9. I haven't checked to see if they upgraded it or not. But then there is earthquakes that they have not reported. Well, we're not surprised, are we? This one here is marked in red. For today, they are only reporting one earthquake, a magnitude 2.8 by Stanley, Idaho. Now, the Snake River Plateau, they know that, 35 miles out in both directions, that it is still being affected from past eruptions. Going all the way up to where it is now there at Yellowstone. Yellowstone has 2 different areas where the plume of magma comes into the system. One up from the Snake River Plateau and then moving across. And then the other one from the Gulf of Mexico coming up all the way from down there to Yellowstone. The hot spot for the Snake River Plateau, that moves across and into the Madison River and the Norris Geyser Basin. The one coming up from the Gulf of Mexico comes up somewhere over here on the eastern side of the lake, goes under the lake, and then comes up and moves north. Alright, so this earthquake at 1826 shows up here at Norris Junction and at Madison River. Let me pull this up a little bit. Doesn't really show up here at Yellowstone Lake, and it's marked in red. Remember, that's meaning that the computer picked it up, sends a message to the geologist, and they're supposed to come in and review it. So it's a small earthquake with what looks like some more magma that came into the system afterwards. This comes in as a magnitude 1.42. It's a small earthquake, but it did bring up a lot of heat. Remember, not all rock melts at the same temperature, and gases. And don't that look a lot better than what it was, a week and a half, 2 weeks ago, where it was showing so much red? We got another one marked in red right here. Let's see, 1956, not being reported. That one comes in as a 1.37, another very small earthquake. But look at the heat that came up. Yep. That earthquake too shows up on 2 monitors. Let's look at the signature again. Alright, this is Madison River. Here we have Norris Geyser Basin just as a little blip. And then the Yellowstone monitor, yeah, didn't really record there. Very small. Alright, we got another earthquake, or actually 2 earthquakes that show up at Madison River and at the Norris Geyser Basin. And once again, it does not really show up at the Yellowstone borehole 208. Alright. It's the weekend, so they don't bother reporting them, but this first one comes in as a 1.14. And the second one comes in as a 0.96. These would all be considered microquakes, small quakes. But you can see the line of melt down here. Now this, again, is the Madison River area. Alright, 1703, an earthquake that shows up on all 3 monitors that is not being reported. This is not the 2.8 that came in at 1744 later. This one comes in as a 1.53. Here's the signature for the Norris Geyser Basin, 1.53. It shouldn't matter where the earthquake comes in at. It always should be the same magnitude. Here it is for Yellowstone Lake, 1.53. 1634, there's a very small microquake. See the little red line as it moves across to the different monitors? So it doesn't really show up at the other 2 monitors, just Yellowstone Lake. I mean, there's just a very small blip there at Madison River, if you can even see it. That comes in as a 0.83. And we'll go to the spectrogram. But notice the coloring. It is so much better than what it was before. And we still got blobs of magma coming in. You can see the pockets of melt there. This is what it was showing when I pulled the file. It is so much better than before. It looks like we got a little... Let's check out the signature there. Yeah, we still got harmonic tremors going on. Let me make that bigger for you. Yeah. There's some more here marked in red right here at 1550. I'm not going to try and figure that one out. And then we got, I think I did that one. Yeah, I did that one, 1634. And then we got another one. Where is it? Marked in red. Yeah, let's make that bigger. Yeah, harmonic tremors. This is what they call blobs of magma as it came into the system. Alright, another one not being reported. Just after 8:03, just before 8:04. It shows up there at the Norris Geyser Basin and the borehole for Yellowstone Lake, both of them. That comes in as a 1.57. Another microquake. Yeah, look at that. We may not have hot dike intrusion right now at Yellowstone Lake, but the pockets of melt, yeah, they're still being heated, as you can see here. Yeah. I'm just going to bring this up a little bit so you can see it. There's a line of melt there. And let's take a look at that little blip. And there's another one there. Oh, that's the one in red. Okay. If you look at the thumbnails, you'll notice here at Holmes Hill, Maple Creek, yeah, really, those 2 earthquakes really shook up the Caldera. There at Parker Peak. So I'm waiting to download Little West Thumb and the Promontory data. Thought I'd take a look at what's going on here. It looks like they're looking at Old Faithful right now. You have the dead trees along here, along the ridge. You know where the fault lines are at, because as the gas comes up, it kills the trees from the roots up. They're now saying that the caldera itself is 50 miles by 70 miles. No longer the 35 by 50. So I guess all their new research, they figured out the caldera itself is actually much larger. They're saying, dude, don't call it a super volcano. Well, anything that will produce a tremendous amount of volume of magma and lava and ash is classified as a super volcano. Yeah, they're waiting for Old Faithful to go off. Michael Pollan, the scientist in charge, keeps saying, don't call it a super volcano, it's not. Well, on the USGS Facts, what is a super volcano webpage, it says here the term for a super volcano implies that a volcanic center that has an eruption of a magnitude 8 on the Volcano Explosivity Index, VEI, meaning that at one point in time it erupted more than 1,000 cubic kilometers, 240 cubic miles of material. In the early 2000s, the term super eruption began being used as a catchy way to describe VEI-8 eruptions. The largest, in parentheses, super eruption at Yellowstone, 2.1 million years ago, had a volume of 2,450 cubic kilometers. Like many other caldera-forming volcanoes, most of Yellowstone's many eruptions were smaller than a VE8. Well, we know that. There's been 40 smaller eruptions since the last super eruption, which was 635,000 years ago. So here they have an image, how much magma erupts. Toba, 2,800 kilometers. Yellowstone and Huckleberry, number 2. Yeah, the biggest one was Toba. Was 2,450 kilometers. And the third largest eruption in the world, once again, was Yellowstone, 640,000 years ago. Now that was 1,000 kilometers. Then we got Long Valley, and then another smaller one for Yellowstone, Mesa Falls. So I guess you can say that the term supervolcano is the latest slang that USGS just hates people to use. A reference that's been used for 21 years. Doing a Google search, okay, so supposedly Yellowstone's caldera is now 50 by 70. Toba is 35 by 100. So yeah, I guess I've been wrong. Toba would be the largest caldera in the world, second being Yellowstone. Currently, there is no deformation for Toba. Global Volcanism Program is not aware of any Holocene, which means recent, eruptions from Toba. Let's see, this volcano has had large eruptions of VE4 prior to 10,000 years ago. Whereas Yellowstone does have deformation, it rises and goes down. It's higher now, or just as high as it was when they first started keeping track of it. We know there's been eruptions, such as craters of the moon, about 10,000 years ago. It's legends that has been passed down by Native Americans. So here on the left, we got Little West Thumb. On the right, the promontory. And this is that earthquake as it came in. Let's see, do I have the right line? Yeah, brought up a lot of gas. Shook up. Let's go down here. I wanted to show you down here. Yeah, we're still seeing. Let me see if I can get this again. There. Yeah, we still got stuff going on at the lake. Like I talked about the crack that's down there. There's one earthquake marked in red at 8:03 Universal Time. Shows up on both the monitors there. Right there. See the line going across, and it extends over. We got another one marked in red down here at 1703. But it too is showing improvement, but we're still having, yeah, let me make this one bigger for the little west thumb. We're still showing earthquakes. That's bringing up magma. Okay, that one's not bad. That one's not bad. Yeah, it's really improved a lot from 2 weeks ago. Well, there. That one's not good. Let's look at its signature. Yeah, popping. See, we still got that popping. Yeah. Let's take a look at this one here. Yeah. But not as bad as it was before. Yeah, it's all up to God whenever he decides that Yellowstone's going to erupt. Got another one up there. I have to close that. Some reason when I open it, sometimes it just shows them really small. That's one in red. That one's in red. What else? And then the little stuff. More popping that's currently going on. And I showed you how the magma's coming into the system. The blobs of magma. Pop, pop, pop. Little West Thumb has a few marked in red. Where's this one at? Right there. And there's another one above it, if I can find it. Somewhere in there. There we go. Yeah, it's settled down a lot, but it's still active. It's still recharging. Yeah, the promontory for that Alaska earthquake as it came in brought up gases, but that is such an improvement, I'm glad to say, from before. And then we got some other small stuff down here. Yeah, let's look at the signature there. Yep. And this is what it was showing while I was yakking and you guys were waiting. And then we'll go back to Little West Thumb, what it was showing. Yeah, tectonic, or excuse me, volcanic earthquakes, I'm sorry. And that, I want to take a look at its signature. Right there. Yeah, 2235. And then there's another one that might be significant. 2240. So that's all I have for you right now. Any thoughts or comments or questions, please put it down below. Thank you for watching. Thank you for subscribing. Thank you very much for your support. I really appreciate it. Please stay safe, and I will talk to you later. God bless you. Bye.